stresses calculated on how the structure is loaded. Okay, so from here we plot 3D Mohr circle. Okay, we plot 3D Mohr circle. So this is normal stress, shearing stress. Okay, so this is our normal stress. This is our shearing stress. Element rotate clockwise, element rotate anti-clockwise. So we know that this is our stress Y line. So this is our stress Y line. Then our stress X and stress Z are on the 0 line. Okay? And we know that our stress Z, okay, is equal to 0. So let me label over here first. Okay, so this is our Z point, Y, and this is our X. Okay? So we are very sure that Z has 0 normal stress and 0 shearing stress. Okay? And then the next thing that we want to draw or figure out on our Mohr circle, okay, is where is our X and Y point, right? So I'm gonna, again, this is our shear. And then this is also our shear. And based on element rotation, point Y, the element will be going clockwise based on this shear over here. So this is our point Y. And X is 0 and is going in an anti-clockwise direction. Okay, so this is our point X. So we can draw our line, right? And then we can construct our Mohr circle. So we are aware that this Mohr circle is for our our XY plane, our XY plane. So we know that this is our in plane because the surface area is the largest. So this plane over here, right, has the largest area. So it's usually known as our in plane. The smaller area are out plane. Okay. So in 3D Mohr circle, we usually call our principal stresses stress A, small a, and this is stress B. Okay, so I'm going to draw the other two circles, okay, because this is 3D Mohr circle. So I've done this quite a bit on the previous lecture, right? So the next circle over here is this one over here now. So this belongs to our XZ plane, which is the out of plane. And the last one which is the one I'm currently drawing. this belongs to the YZ plane. And this is also out of plane. Okay, right. So we got this from our structure analysis, but how is the data on the left hand side relate to the right hand side? Yes or no? There is a link. Okay, so what is this link? So if I'm going to zoom in over here again. Okay, I'm going to impose the data on the material properties into our structure analysis. Okay, so this is how it happens. It's the integration that is of value now. Okay, so we know that the normal stress has we know there's a U strength. Okay, so the U strength is, wait, hold on, 2, 4, 6. Okay, so we have over here our minus stress U. Okay, because it's a compression. Now I picked that point deliberately that it is bigger than the 3D Mohr circle. Okay, later on I'll explain what is going on. Then on the other side, over here, this is our stress U, positive. Okay, this is our normal stress. And in general, based on maximum, based on maximum shear stress criteria, okay, or another words, if you look at this data, or if you see the maximum shear stress criteria, they usually call it Tresca criteria, which I will teach next week. Okay. Okay. So based on the maximum shear stress criteria, the stress U, or the maximum shear stress, is U equal to the U stress divided by 2. Okay, so over here, this is your tau max, which is equal to stress U divided by 2, and over here is your minus tau max, which is equal to minus stress U over 2. So from here, we can construct a box, a rectangular, not a box. I do apologize. So 2, 4, 6, 8, 10, 2, 4, 5, and this is the box that we construct. Okay, this is so this box over here is based on material mechanical property. Okay, and the 3D Mohr circle here. Okay, so the 3D Mohr circle that you see inside there, it cannot be bigger. Okay, it cannot be bigger. It cannot. The circle cannot be in the shaded region. Okay, so this is the shaded region. So I'm going to write down here the 3D Mohr circle from structure analysis cannot be in the shaded region. Okay, if it does, material will go into plastic deformation. Okay. You go into plastic deformation for ductile material, or fracture for brittle material like concrete, okay, or cement, right? So if it's within the shaded region, it will not yield. If the circle is bigger than the shaded region, it will yield. Okay, so this is it. So this is how we link the data or the information on material behavior from unit Excel tests to structure analysis and to plot into 3D Mohr circle like this, right, to see whether the material will fail or not. Okay. Okay, so that is enough theory. Okay, what I'm going to do is I'm going to work onto one example. Okay, so if you were to go onto Avenue to Learn, you can download this example. And this example, I have also attached the solution provided by the publisher. And I want to avoid, or I want you all to construct 3D Mohr circle on your own rather than looking at the results from the publisher. Okay, because what I'm going to teach you is so much more easier to implement than using what the publisher or what the solution menu is dealing with. Okay, so let me get the question first. So example number 1. Okay, so this is the question over here, and I'll get the solution. Usually the solution provided by the textbook is highly complex. Okay, and I don't want you all to use the, like, you guys have been in this course for 11 weeks already, right? And you guys realize that the method that I teach is so much more straightforward. I hope so, that it's so much more straightforward than the solution provided by the solution manual. Okay, let's look into this question first. So for the stress state shown, determine two values of stress Y for which the maximum shear stress is 75 megapascal. Okay, so we are going to find two values, okay, of stress Y, and we are given that tau max is sitting at 75 megapascal. Okay, so the two values of stress Y is controlled by the what? By the maximum shear stress of 75 megapascal. Okay, the maximum shear stress for this case, they did not mention whether it should be in plane or out of plane. Okay, so i.e. either in plane or out of plane, the maximum shear stress can only go up to 75 megapascal. Okay, so I'm going to copy this question over here, and we are going to start drawing the Mohr circle, 3D Mohr circle. Okay, so this is in 3D Mohr circle. So given the information that we have, we know that stress X is equal to minus 70